33 x y to the 8th power, and then z, I'm sorry, y to the 7th power. Yeah, x and then y to the 7th power, and then z.
Like this?
Yes.
Okay.
And then on the bottom, it's 13 x to the 6th power, y to the 4th power, and z.
Okay. So you take it one at a time. You take the numbers first, 33 and 13, and I simplify that in any way.
Yes.
No.
Or no?
13 is prime. Nothing comes out of it, right? So I know those are going to stay where they are. Now let's look at the x's. I have x to the 1 minus x to the 6. So 1 minus 6 is negative 5. But does it go on the top or the bottom? Thank you.
Until you switch it, it would go on the top.
You could either say x to the negative 5 or go ahead and write it down here.
Yeah.
Does that make sense?
Yeah.
So it's okay if you want to write 1 minus 6 is a negative 5 and it stays on the top. But eventually at the end it's going to have to move to the bottom because we have to get rid of the negative. Then what about the y?
I'm going to subtract.
Y cubed and then the z's cancel. Okay. Another way to look at it is just envision. I have one x here and I have 6 x's down here. So if I cancel out what's the same, I have 5 left down here. Okay.
That's not a negative, right? You don't have to flip it?
Well, it would be, but it can't stay on the top.
It could be written like this.
Right, okay, so it'd just be easier to leave it on the bottom.
Exactly, because you can't leave a negative exponent in your answer, so eventually you're going to have to make it work.
Okay.
Does that help?
Yeah.
Okay. Did you guys do that worksheet?
I didn't.
I tried.
Okay.
I did the homework though.
Any other specific questions before we get started? Renee? And I'll get into it. Number 3 on the practice sheet. Okay. Find it. For those of you who weren't here, let me give you a practice sheet. Anybody else that wasn't here? What did you guys work at? Oh, yeah. Okay. You guys have to look at your test.
You have it? Is that on there or no? I just want to look at it.
Okay, number 3. X to the 4th, y to the 6th, all cubed. 3x squared, y to the 5th, all to the 4th. Okay, what we're needing to do is multiply these, but before we multiply them, we have to get rid of the exponents on the outside. Just like order of operations we did before. Parentheses first, then exponents. Since there's nothing within the parentheses to clean up, we're going to do exponents next. So this 3 gets taken to every term because of the power rule. So this becomes x to the 12th, y to the 18th. Because when we raise a power to a power, we multiply the exponents. In this one, I also have to take this 3 to the 4th. So what would that be? 81, x to the 8th, y to the 20th. Okay, I've gotten rid of the exponents on the outside. Now I can multiply the 2 terms. 1, there's no number here, so imaginary 1 times 81 just leaves 81. x12 times x to the 8th becomes what? X to the 20th, because by the product rule, when we multiply 2 things of the same base, 2 terms same base, we add the exponents. So what would y be? 38. Okay, so this was a good problem because we had to use the power rule, and then we had to use the product rule. Yes, when you multiply with the same base, you add. When you're raising them, you multiply. Okay, Keely, what was your question?
I just want to check the answers was right for the first one.
Okay.
On the practice.
The first one?
Mm-hmm.
Does that say 9?
Yes.
Okay. I don't have my glasses, I can only see. 9, 1, 12. Okay. So first we're going to simplify the constants. 35 over 15. How can I simplify that?
7/3.
7 on the top, 3 on the bottom. Then we have x to the 4th over x to the 9th. Who ends up with more x's?
Bottom.
The denominator. How many?
5.
5. Does everybody see that?
Mm-hmm.
Okay. How about here? We have 9 on top, 12 on bottom. Where do we have the most left? Where are you down here?
Alright, yes.
Okay? Any questions on that? All right. Let me hand out some quizzes. There's only 10 problems. Yeah. So that was just a simple math error. Only 2 of you. Okay, oh. Did I get everybody's? Scott, I get your. Okay. I will grade these and get them back to you next time. Today we're going to start 4.3 and do 4.4. 4.3 is about scientific notation. As I wrote up here, and this definition's in your book as well, scientific notation is a number written as a number greater than or equal to 1 and less than 10. It's multiplied by some power of 10. This is it written generically. A has to be a number between 1 and 10, less than 10, and B is just an integer. Why do we use this? We use this, yes ma'am.
Does that mean it has to be a whole number?
Here?
Here? A whole number
Yes.
between 1 and 10?
Yes, a whole number. Yes, that's a good point. It does, yes. That
Okay.
A whole number. Well, I should correct that. It can be written like 6.4, Shannon, and that's not a whole number, but the number in front of the decimal point has to be a whole number.
Okay.
You'll see when we get
So we're using decimals as well?
Yes, we are.
Okay.
We're going to use some decimals.
Okay.
So no, it is not a whole number, just the number in front of the decimal. It's difficult to write really large or really small numbers, like the world's population or the distance from the Earth to the Sun. So we use scientific notation a lot to describe really big or really small numbers. So a way that we would rewrite, this isn't a really big number, but just an example, 68,400. To write it in scientific notation, we would move our decimal point all the way till there is one integer in front of the decimal that's between 1 and 10, or 1 and 9. And we would say 6.84 times 10, and then we count how many times we moved it. 1, 2, 3, 4. 4 times to the left. So this is scientific notation of this number. Another way to think about it is that 6.84 times 10,000. If you multiply that, you will get 68,400. And 10 to the 4th is just another way to write 10,000. Okay. So let's talk about how we go from a number to scientific notation, how we go back and forth. As I just showed you in this example, the first step is to move the decimal point to the right of the first non-zero digit. So in my example, I moved it to the right of the 6. You move it to the right of the first non-zero digit. Second, you count the number of places you move the decimal point. So this is important. If the original number was 10 or greater, the count will be positive. Okay? So that just means if we have a number 10 or greater, we're going to be moving it left, meaning it will be a number greater than 10. If we end up moving to the right, it's going to be a number less than 10. Okay, the final step.
So what if it equals 10?
If it equals 10, it's 10 or greater. So it would be positive. Because what we're doing is we're making groups of 10. Like this 10,000 is 4 groups of 10. So every time I have a group of 10, I will be adding a number. So it includes 10. The final step is to multiply the number by 10 raised to the power found in step 2. This is a lot of verbiage for something that really is not that hard. When we start doing examples, you'll get the hang of it. Okay, the hardest part is to know if we're going left or we're going right. And we have a big number or a small number. Let's go over some, and I think it will be clearer. The first example, 18,500. Let's look at our steps. Our first step is to move the decimal point to the right of the first non-zero digit. So where am I going to move the decimal? Between the 1 and 8. So 1, 2, 3, 4 times. 1.85. Why don't I have to write the zeros?
Because you're going to multiply it times 10 to
So-
the 4th.
Yes, and if I put zeros at the end of decimal points, do they matter? No, they don't mean anything. So 1.85. Then I'm going to raise it to the power of 10 of how many times I moved my decimal place, which was what? 4. Now, why is it a positive 4? Because this original number, 18,500, is greater than 10. Here's an example when it's not greater than 10. Here's the number I'm starting with. My first step is the same. I still have to move my decimal point to the right of the first non-zero digit. My first non-zero digit is 4. So I have to go 1, 2, 3, 4, 5. So I have 4.16 times 10. Now this time my original number was less than 10. It was a decimal. So it's a negative 5. So it's a positive exponent if I have a number that is large. It's negative if I have a small number or a decimal number. Another way to look at it, if you move left, it's going to be positive. If you move right, it's going to be negative. Because look at it going back. If I had to turn this back into a number, I'm multiplying this by 10 to the 4th, which is 10,000. So it's going to blow up. If I multiply by 10 to the negative 5th, it's 1 over 1, 2, 3, 4, 5. 1 over 100,000, which means it's going to get smaller. Because remember we talked about negative exponents needs to flip. So this is 1 over 100,000. So you just have to get that right in your head.
And can you, when we do that, we don't have to show it going into a fraction. We can just take the negative 5 and move it.
Oh yeah, I'm just
Okay.
showing you
Oh my
why
gosh.
it's like
Okay.
that. Wait. Let's try another one. Okay, so what can I rewrite this as scientific notation? 3.721 times 10 to the 1, 2, 3, 4, 5, 6. Positive or negative?
Positive.
Good. This time I'm going to write it as 9.3 times 10. 1, 2, 3, I moved it 3, and it'll be negative because I moved to the right. Okay, not too hard, right? Okay, now what about if we're going backwards? They gave us scientific notation, and now we have to go to a number. Wouldn't you think we're just going to go the other way? So, this is scientific notation back to a number. First, we observe the exponent of the power of 10. In other words, we're going to see if it's a positive or a negative number. Then, if the exponent is positive, move the decimal point to the right. may need to add some zeros.
So it's basically the opposite of the first group.
Exactly.
Okay.
But if the exponent is 0, what does that mean?
1.
Yes, good. Do not move the decimal point. Because 10 to the 0 is just 1, so it doesn't move. And last, if the exponent is negative, move the decimal point which way? To the left. Okay? So it's the opposite of going from the number to scientific notation. I'll give you a second to write that down and then we'll look at an example. That's kind of chicken scratch. You can't read something funny. I agree with you about that. It's also in your book. Another way to think about this is when I'm turning this back into a number, if this 4 is positive, this means 10,000. It means I'm blowing it up. So which way does it make sense for the decimal to go? To the right, because I'm making it bigger. Okay, I'm making a larger number. So I have to move this decimal point 4 times to the left. So 1, 2, 3, 4. A lot of times you have to add the zeros. So another way to write 2.9 times 10 to the 4th is 29,000. Okay? 6.28 times 10 to the negative 3. Which way am I moving my decimal? Left. Because this is negative, I want this to be a smaller number. So I'm going to move 3 left. 1, 2, 3. Now when you do this, make sure you put a 0 in front of the decimal, because that's the correct way to write it. Okay, so you're going to have to add some zeros. Always go back and check yourself. 1, 2, 3, yep, that's where I started. Because sometimes you get kind of crazy with the zeros and you might add 1 too many or leave 1 out. So always go back and check yourself. Okay, so look at another one. Okay, is this number getting bigger or smaller? Bigger. Which way do I move the decimal? To the right, 8 times. 1, 2, 3, 4, 5, 6, 7, 8, comma, comma. Check myself. 1, 2, 3, 4, 5, 6, 7, 8. Got the hang of it? Okay. So that's it for writing the scientific notation from one way to the other. Now we're going to learn how to use scientific notation in some different operations. Okay, we know the metric system is used throughout the world, right? Millimeter, centimeter, those things. Well, each of those prefixes stand for a power of 10. For example, a nanometer is actually 10 to the negative 9. Because it's 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 over a billion. A micro is 10 to the negative 6. Milli, 10 to the negative 3. A kilo, and this is where the meter, the base is. So everything above is negative, everything below will be positive. A kilometer is 10 to the 3, so you multiply it times 1,000. Instead of multiplying by 1,000, you convert it as 10 to the 3rd. A mega, anybody know?
10 to the 6.
6 and a giga.
10 to the 9.
10 to the 9. Good. So if no numerical coefficient is indicated, you assume it to be 1. So if I said 1 kilometer, it's 1,000. But if I said 4 kilometers, it'd be how many? 4,000. Okay? So let's look at an example of how we're going to rewrite things with metric terms into scientific notation. What if I wanted to write 76 millimeters without the metric prefix? Then it would be 76 times, what's a milli? 10 to the negative 3. Can I leave it like this?
No.
Why isn't that scientific notation here?
It's not between 1 and 10.
It's not between the 7 and the 6. Remember? Yeah, the first number's not between 1 and 10. We have to move it so the decimal point only has a number between 1 and 10. Actually, less than 10, 1 and 9. So I have to write this as 7.6 times 10. What did I do? I just moved it once to the left. So what does negative 3 become? Negative 4. Very good. Nope, wrong way. It's negative 2, because I actually added a 10. Remember when I go from a number to scientific notation and I go left, it's a positive. Let me write a shorthand here. If I go number to scientific notation, then left, moving the decimal left is positive, right is negative. This is just a way to help you remember, okay? If I'm going from scientific notation back to a number, then when I move left, it's negative, right is positive. Or bigger, bigger, smaller. Does that make any sense?
Yeah, because it would be like 76 1,000.
Because think about going from 7.6 back to 76. What did I have to multiply that by? 10. A 10. So what I really did by moving it this way is I put the 10 over here. That's why instead of negative 3, it's negative 2, because I added a 10. I see a lot of blanks here. We're going to go over this some more.
I just don't understand why I can't start from the back of the 6 and just go over it for these spots. I get where you're saying adding the 10 and it has to be, I don't know, it's just hard to grasp.
Because if you started at the 76 and went over 3, you wouldn't have the right number for the scientific notation. So you'd have to move it over 2, so it ended up being 7.6 anyways, with 10 to the negative 2.
From 0, so 0 from 0 to 0.
Yes, but we want to write it in scientific notation. We don't want it back as a number.
Okay.
Okay, our goal was to get rid of the millimeter and write it in scientific notation. But to go from 76 millimeters to here, we had to say 76 millimeters, whatever the millimeters represents. Then I have to turn it into scientific notation, so I need to move it once to the left.
Okay. Because it has to be in this one. Okay.
And why this went from negative 3 to negative 2, let me give you an example. What if I just said 76 and I wanted to write that in scientific notation? Be 7.6 times 10 to the what? 1. Right? Because I moved it once to the left. That's what I did from here to here.
Okay.
I just happened to already have a negative 3, so when I had 10 to the 1,
Move it up to the
I moved it up. Yes.
I still don't understand why it has to be scientific notation. You said it has to be scientific notation, but why is that scientific notation?
Scientific notation, by definition, this first number has to be between 1 and 10. This number has to be between 1 and less than 10. Because that's what scientific notation is. I can't have this number be greater than 10. Okay? Alright, let's do some more until you guys get it.
Are we
Alright.
gonna need to learn the symbols for each of the, prefix, or for each of the,
The prefixes, yes.
yeah, okay.
You do want to know those. I only wrote 6, so that's not too many to learn. Write 183 nanoseconds without the prefix. Okay. So I'm going to start by just saying it's 183, and how do I rewrite a nanosecond? To the -9. So that's my first step, is just rewrite the nano as 10 to the -9. Now I have to put it in scientific notation.
1.83
So-
times 10 to the -7.
Good. So why she did that is I have to go back to a number between 1 and 10, so I had to move my decimal twice to the left. And when I moved it twice to the left, am I adding an exponent or subtracting? I'm adding exponents because I'm doing it by 100. So instead of -9, it is -7 because I added 2 tenths. And if you don't get from here to here, take this to the side and just say, how would I rewrite 183? 1.83 times 10 to the 2, right? So if I know that's how I'm going to rewrite it, I just have to put this 2 with the -9 and realize I have -7. If you're not seeing it from here to here, take this one extra step.
So if you had like 0.183 nanosecond, you would do, you would just add,
Then you-
like, so it'd be
It'd be -10.
1.83 times 10.
She's saying, what if this said I had 0.183 nanos? Then I would write it first like this, and then I'd have to move this once to the right. If I moved it once to the right, I'm getting smaller, so this would be -10. So when you go from a number to scientific notation and you go right, you have a negative. If you go left, you have positive. Okay, one more of these for right now. 50 micrometers. How can I rewrite that? 50 times 10 to the right. -6, okay? I have to put in scientific notation, so I have to move it once to the left. So am I adding a 10 or subtracting a 10? Adding. 5.0 times 10 to the -5. So I'm adding 110 to the -6. Okay. Don't worry too much about it yet. We're going to get this down with more practice. The hardest part is just the going left to right. Trying to remember, is it a +2 or a -2? Okay. Now what about doing calculations with scientific notation? What if I had to multiply these two scientific numbers? This is actually real easy. You just take the whole number, 2.8 and 3, and multiply that. So first I say 2.8 times 3, and that would give me 8.4. Then I say times 10, and what do I do when I multiply two numbers with exponents? We learned it last time. We add them. So what's it going to be? 4. Okay, times 10 to the 7th and 10 to the -3. So that becomes 4. So multiplying those two numbers, I get 8.4 times 10 to the 4th. If it didn't come out nice and neat where it was a number between 1 and 10 point, then I would have to do like I did over here and move it so that it was in scientific notation. Does everybody understand how to multiply? So you just multiply the whole numbers, and then you add the exponents of the tens. Okay, let's look at the division.
Is that only one? Is the bottom equal 4 times 10? back to the 4th? They don't want us to finish it?
That is finished.
Oh, okay.
Yep. That would be it, unless it wasn't written in scientific notation already, but it is.
If it wasn't written in scientific notation already, like if one of them was and one of them wasn't, would you write it in scientific notation before you solve it?
Yes. Good question. You would. So if this had started out as 28 times 10 to the 6, then I'd want to change it to 2.8 times 10 to the 7 before I started. That's a real good question. Okay, in division it works the same way. You first divide the whole numbers. Well, I shouldn't say whole, you divide the numbers. And you get 2.0. Then what do I do with the exponents of the tens? You subtract it. So negative 3 minus a minus 7 would make that a positive 4. Negative 3 minus minus 7 would be a positive 4. Okay. Let's look at a problem if it said the weight of Earth is 5.972 times 10 to the 24 kilograms. The weight of Earth's moon is 7.35 times 10 to the 22nd kilograms. The question is, how much greater is Earth than the moon? Kilograms. Right now we're not converting the kilograms to anything. We're just working with the numbers. So both kilograms. So when we're taking the difference, we don't have to change anything. But if I'm asking how much greater is Earth than the moon, what kind of operation am I doing? Subtraction. Good. So I'm going to take the smaller from the bigger. So the bigger goes on top, minus the smaller. Remember, when we subtract decimals, we line up by digit. So I'm going to fill in a 0 here under the 2, because I'm lining up by digit. Before I start a subtraction problem or addition problem, it's different than multiplication division. Because with multiplication division, I could add the exponents or subtract the exponents. When you're adding and subtracting, these have to be the same. Your exponents have to be the same to add and subtract. One minute.
Because we put that 0 there, you wouldn't take it from
No, because when you add a decimal to the right, a 0 to the right of the decimal, it doesn't change its value. It's just adding it for a fill. Now, if you had put it in like over here, like if you change a 7 to a 70, then yes, it changes its number. But if it's over here to the right, it doesn't matter how many zeros I put here. Does that make sense? So I have to change one of these to look like the other, to have the same exponent before I subtract them.
Would you just move it, the decimal?
That's what we're going to do. So I can either move this decimal to make this a 24, or I can move this decimal to make this a 22. If I want to make this one a 22, which way am I moving? Left. No. No. Because to make that 22, I'm taking 2 away. So if I take 2 tens away,
I pointed that way.
I have to put 2 tens over here.
So
does that make sense? Like, if I'm taking 2 tens, which is 100, I'm taking away 100, the 100 has to go back over here. So it's moving right.
That's what I meant. I just went left. I pointed.
if you have a calculator, but we're not doing that. You're saying, can I just plug this into my calculator? Well, of course you could. 597.2 times 10 to the 22. So I had to change this to be an exponent of 22. So I had to move my decimal to the right. Yes.
And if you end up changing the one that has the 22 already to 24, would that one be the one that goes on top then, since it's more ends up being?
No. You would not. And if I wanted to make this 24, I'm adding 2 tens, so which way am I moving this decimal? To the left. I need these to match the exponents. Okay? So I need this 24 to be a 22. In order for it to be a 22, how many of these tens am I taking away? Okay. Let me think of a different one. If I want this to have 10 to the 22, how many am I reducing it by? 2. I'm taking away 2, right? So I'm taking away 2 tenths, or 10 to the square. If I take 2 tens away, which is 100, it didn't go away into outer space. I have to put it back into the number. So I have to move it twice this way. Okay? Just like if I had a number like this, and I need to write it in scientific notation. To write it in scientific notation, I'm moving this twice to the left, right? 7.932 times 10 to the what? To the 2, because you'll move it 2 that way, right? So if I have to reverse it, if I have to take these 2 away and go back here, which way did I just move my decimal to go back? I had to move it back right to go back to my original number. I had to take this away. That's what I'm doing here. I'm taking 2 away, so I'm having to move it twice to the right.
Is it possible to like just minus 5.972 from that and then do times 10 to the second? Like that wouldn't make sense to do that? Is that what we're doing?
Yeah.
Okay.
It would work.
Because I was looking at it, so I really just.
Yeah. You have to have the same exponents when you're adding them. Let's pretend we understood all that. And finish the calculation, and then we'll go back and do this again, okay? I just want to finish this computation first. Okay, what do I have to fill in above the 5 to do subtraction? A 0, a filler 0, because now I'm subtracting these 2 decimal numbers. And when I subtract them, I get 589.85 times 10 to the 22, because now they're both the same. I can take them away. Okay? I'm sorry?
Didn't you have to change the word?
For my final answer, yes. So now is this in scientific notation? No.
No.
I have to write it back in scientific notation. So it's 5.8985 times 10 to the what? 24.
What?
No.
20.
What? What? No. 24. You guys are confusing me.
You went to the left one, you had it.
Because it's positive.
Because it's positive. Now I'm taking 10 away and I'm moving them over here. We need to go back to the beginning and understand the basics of scientific notation.
If you write out the numbers the long way, it shows you easier.
If you what?
If you write them out the long way, like if you ever just wrote out all the rest of your 20 zeros after your 4 decimal places,
Yeah, and
it
you
would
how
show
you
you.
wrote them. it would be a lot easier.
Write out all the zeros. 22 zeros?
If you want, no, 20. If you wanted to.
It just to visually
Yeah.
see it?
Right.
Yeah, okay.
Yeah, but then why didn't you change it to 24 to begin with? I didn't change it.
You know what, it wasn't.
Like, why do we move it from the 20, move the top one to be 22?
You can. At the beginning, I said it doesn't matter which one you change as long as they're the same.
But then when the vacuum on it would be like 0.0072.
Still
Well,
gonna
let's
come
do
out
it
the
that way.
same.
Let's do it that way. Okay, let's try the other way. Okay, you want them both to be 24 instead. So, how do I have to change this to 24? I'm going to move my decimal 2 to the left. So it's going to be right? Mm-hmm. Okay, now let's subtract. 5.972 minus 0.0735. Filler 0. There you go. Works out the same way. Okay? So it doesn't matter if you change the 22 to a 24 or the 24 to a 22. It will come out the same in the end. The point is when you add or subtract, with exponents, they have to be the same.
Number needs to be in the second digit.
And your final answer needs to be the second digit. Better or worse? Or not better? Let's press on and we're going to do another one like that, okay? I have one last thing to tell you for scientific notation, then we're going to try some together. What if I have a question that says, how many times greater is the weight of Earth than the moon? So now I'm not asking for the difference, I'm asking how many times greater it is. So what kind of operation do you have to do? Division. So my numbers are still over there. I'm going to take the weight of the Earth and divide it by the weight of the moon. Do I have to change any of these exponents to do division? I don't. Good. So all I do here is I divide 5.972 by 7.35 in my calculator. And I get 0.8125 times 10 to the what? Second. Good. It's 24 minus 22. Am I finished?
No.
No, because I have to put this in what? Scientific notation. So it's 8.125. Which way did I have to move my decimal?
The right.
Once to the right. So am I adding or subtracting?
Subtracting. Right, it's subtracting. Okay.
Okay. Yes.
Now what I think would help is if
You're not taking
you
away from it.
included
Hold on a second, I'm not done with that.
this that you had up earlier,
Mm-hmm.
that would, include these with, I think that would help a little.
You mean write it up on the board?
Uh-huh.
Okay. So my little shorthand notes, Shannon's asking me to keep them up on the board for you guys.
I think it would help
Okay.
so that we could remember if we're going left
So
or
let's
right.
do this. If I'm going from a number to scientific notation, move the decimal decimal left, then you are adding tens. Would adding tens make sense, or positive exponent? How would you want me to say that?
When you say adding tens, do you mean you're adding a number to your exponent? Or
Yes.
are you taking the number away?
Yes, it's positive. I'm going to say positive. You have a positive exponent. Okay? Does that make more sense?
They just use to the 10th. They don't call it, they don't say exponent when they've written out the rules.
Okay. If you move your decimal to the right, then it would be negative. If you're going from a scientific notation back to a number, then what? If you move the decimal left, it's going to be negative. You're taking away. If you move your decimal right, then it should be positive. So in this one, I don't think we have it right. We moved our decimal to the right. And we're going from a number to scientific notation. So,
You do have it.
We do have
I
it,
do have
we
it
took it away.
Take it away. Does that help at all?
Yeah.
Okay. That makes sense. Okay. So in all of this, if you can get this right in your head, these will not be hard, okay? You just have to visualize which way am I moving that decimal, and does it go up or does it go down? Yes.
I think they weigh the movie.
Relative
How far
to-
it goes in its regulation.
Yeah, it's a calculation or a formula that they have to put it in. Just like how do they know the height of Pike's Peak?
Really long measurement.
Yeah, they can't just measure it all the way up. You have to use angles. But for weight of things, they would have to take it by mass and.
I was gonna say, wouldn't it be weight equals mass times volume? Is that it? It's been a long time since I
don't
did it,
remember, to be
but
honest.
something like that.
I did learn that once upon a time, but I don't remember. And it could be extrapolation. It could take a part of it and extrapolate it. Okay, so let's try some problems before we go to 4.4, because I definitely don't feel like you guys have this. Let's look at, on page 247, number 17. And it just says, these start out easy. They just want you to write these in scientific notation. And my little nomenclature is not going to work for you guys because would that still be like yes. Okay, that is good. If I need to turn this into scientific notation, I have to move this decimal to the right of the first non-zero digit. So I have 5.3 times 10. Is it going to be positive or negative?
Negative.
Negative. Negative 2. Why?
Because it
Because
says right
think of
there.
going back. If I have to move it back, I want it to be a small number. So I want it to move this way.
Top one.
Yes, Scott.
Number to
Is this like the section we did before, if you're multiplying by a negative, like an exponent, it's like 1 over 10 to the second. So that just means you're moving it smaller.
You're going from bigger to smaller.
Yeah, I think it helps more to make it the first one that you have, and then when you make it in the 1 through 10, since we are a smaller piece and make it a smaller number, then you have to do that. I don't know, I don't move it back from there, I make it the numbers.
And really, honestly, guys, every student is going to think about this different. You just have to get it right in your head, however that is for you. You just have to memorize which way I move it when. But if I'm moving to the right and I'm going from a number to scientific notation, then I'm going to have negative exponents. Okay? If I was moving left, I'd have positive. Let's try another one. Let's try number 18. 18 is 19,000. Okay, this would be 1.9 times 10 to the what? 1, 2, 3, 4. Positive or negative 4?
Positive.
Positive 4. Good. Good, good. Let's look at number 21. 5,260,000,000. Okay, I need to write this in scientific notation. Tell me what it would be. 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive or negative? Positive. Good. Okay, I think you guys get the idea that we're moving it to the right of the first digit, right? 1, 2, 3. 5.104 times 10 to the what?
Negative 4.
Negative 3. 1, 2, 3. I moved right, so it's negative. More of these, or are you good with these? Raise your hand if you want me to do more of these. Okay, so you're getting the idea which way to move it when we're going from a number to scientific. Okay, then let's try number 29, because now we're going to go scientific to a number. Now I want to go back to a number. If it's times 10 to the 4th, is this getting larger or smaller? Larger, so which way am I moving my decimal? Right, how many times? 4. So 1, 2, 3, 4. Check myself. 1, 2, 3, 4. Okay, number 33. 2.13 times 10 to the negative 5. This time, if it's a negative 5, am I making this smaller or bigger?
Smaller.
Smaller. Which way am I moving the decimal?
Left.
Left. 5 times. 1, 2, 3, 4, 5. Check myself. 1, 2, 3, 4, 5. What's the matter, Carolyn?
No, I was just laughing because this is an algebra. It doesn't make sense like algebra. Well, I'm just saying that it was just
Okay. Okay. Sure it is, because when you get in higher algebra, you're going to have to use your numbers, and you're going to use scientific notation.
Yeah. No, I understand.
Okay. All math, all physics, everything, we're going to use this. Let's pick number 45. Before I do the next section, do you understand going from scientific back to number? Are we starting to get this better in our head?
Yeah.
Okay, good.
It helps to have
The thing up there. Okay. And if you don't like this shorthand notation, come up with your own. Just a way to remember that in your head. 8 micrometers. Remember when we did these? So if I want to take the micro, what is it? 10 to the what? Negative 6. So I write 8 times 10 to the negative 6. Am I done in this case? Yeah, because it's already scientific notation.
But you have to put point
That's all they
zero
asked
down
for.
here.
What? No, it's already.
No, I know, but don't you have to put the point zero to make it correct, or can you just leave it at 8? I mean, I know you don't have to change any of the exponents.
You know, scientific notation it probably would be correct to put 8.0. I totally see what you're saying. But you don't have to move it, is my point. We were done
I
with
know.
moving everything, but you should write 8.0.
Did you want us to memorize those?
Yes, there's 6 of them.
Yeah.
Nano, micro, milli, kilo,
Mega, giga.
mega, giga. number 49. 49 is 15.3 kilometers. If I didn't want to write kilometers, I just wanted to write meters, well, how can I change this? 15.3 you start with, times 10, what's a kilo? The third, because it's 1,000. Can I leave it like that? No. No, that's where we got screwed up last time. 1.53. Which way did I just move my decimal place?
To the left.
I moved it to the left. Number to scientific notation, when you move left, you're going positive. So did I add to this or subtract?
You add.
I added.
They can be taught.
51.
I think it's harder in the word problems to understand
Sure.
how you're actually applying this.
The hardest one so far was that subtraction one. That one I think for you guys really. Other than that, everything's been kind of okay. Let's look at this one, milli. What is milli represent? -3. 10 to the -3. So your first step is just to write the numbers they gave it to you times 10 to the -3, because that took the place of milli. Now I have to write it in scientific notation. So I moved it once left. So did I add or did I subtract? If I moved it left, I added. So I have to add one to here, which would make it a
-2.
-2. Good. You get it? Okay.
Can we do another of like the subtracting?
Yeah. I'm getting there.
Oh.
I'm trying to do it in order of what I taught you.
Oh.
Okay, 54. This is a multiplication. You guys are getting kind of mutinous on me.
It's the middle of the semester.
Yeah, you're more comfortable now.
No.
It's either fight or sleep, so.
Okay, so when I multiply, what's my first step? Multiply the numbers. So I think we know 2 times 3 is 6.0. What do I do with my exponents when I'm multiplying?
Add them.
Add them so it becomes
10 to the -1.
Oh, good. Good. Number 59, when I try division. .9 times 10 to the -5 over 3.0 times 10 to the -2. Okay, so what's our first step? Divide. Do I get 1.3? Yes. 1.3 times 10 to the what?
-3.
The exponents? -5 minus a -2 would make that -3. Okay. $65. We didn't do one exactly like this one yet.
Can you do like,
We touched on it.
can you do like either 60 or or 63 or 64, one of those? With the negative exponent variable.
I'm sorry, the what?
With the negative. So if we did 60, it would be 2 times 10
To the -4.
to the -4. Okay.
65. We've done multiplication before, but if it says they want you to multiply using scientific notation, what do I have to do first?
Number 2.
Put them in scientific notation. Okay? So the reason for this is if you don't want to have to multiply 8 million by 700,000, you make your life easier, especially if you don't have a calculator, to write this in scientific notation first. So this would be 7.0 times what?
10 to the 5th power.
And this would be 1, 2, 3, 4, 5, 6. So then when I multiply, I just do the 7 and the 8, and I get 56 times 10 to the 11. Does everybody see that? I have to leave it in scientific notation. I moved it once to the left, so what am I doing?
Taken away.
No. Give it.
Given it.
It's positive, so I'm adding it. Okay? All right. Number 79. 2 more. I'm trying to find you a subtraction one off of it. 79 says, if a computer can do a calculation in 0.00002 seconds, ooh, I don't want to press that. Would it take how long would it take the computer to do 8 trillion? So what kind of operation am I doing in this word problem? Division. Good. So which number am I putting on the top?
Nobody's.
If it takes the computer 8 trillion, how long would it take the computer to do 8 trillion calculations if it can do 0.00002 a second? So which number goes on top? The bigger or the smaller?
The bigger.
I was trying to get to 8 trillion. 0.0 times, is it 12? Thank you. It doesn't give it to you that way in the problem, so you'd have to write it in scientific notation. And then you're going to divide it by, the number was 1, 2, 3, 4, 5, 6. So 2.0 times 10 to the positive or negative 6?
Negative.
Now I have numbers I can work with. Because it gave you the problem with these crazy numbers. We put in scientific notation, it makes it a lot easier. And it's a minus 6, and that'd be 18. Okay, that's a real good example of why scientific notation makes calculating easier. Okay, let's try number, I think it was 82. Yeah, what's the subtraction one? And that's the last I'll do in this section for now. 82. The number of new cases of melanoma has increased from 5.5 times 10 to the 4th in 2003 to about 6.25 times 10 to the 4th in 2008. How much greater was the number of cases in 8 than 03? So subtract, right? And I'm going to take my smaller from my bigger. So the bigger number goes on the top, and I'm subtracting the smaller. Oh, this one's not even fair because I already have it. That's easy. Okay, so they're both 10 to the 4th already. We don't have to change anything. That was a good example. Ooh, what about 83? 83? Is that one that'll work out that way?
They're different.
Okay, yeah. There you go. Perfect. We're going to do 83. Okay, so before I subtract, I have to change one or the other. Which one do you want to change?
Let's do the top.
Make it into a 10. So to add 1 here, what do I have to do with my decimal? Go to the left. Good. Because when I move it left, I get a positive. So to make this positive, to add 1, I have to move this one to the left. Okay? So I get that's not going to work out right unless I put the 6 on the top, which is okay. them because when I moved this to 10 to the 10th, this became smaller. And I can't take a bigger number from smaller. Right? What's the matter? Yeah, that's right. Okay, so let's walk through this again. I had to make them the same exponents. I can either change this to a 9 or that to a 10. We chose to change this one to a 10. In order to up it by 1, because when I move the decimal left, I go positive, I would go one way left. When I did that, this number became smaller than this number. So I have to take smaller from bigger to get the difference between them. So then I just subtract like you normally would and you have to do that. Okay? That's probably the hardest thing in the whole section is the subtraction. And I haven't even looked at the test yet, but I'm guessing that won't be on the test. Even though I have a lot to do. Okay, we're not done, guys. We have to do the next section. 4.4.
Please call it a day.
No. I'm sorry.
I'm gonna try.
Put this now. Okay, 4.4 is the addition and subtraction of polynomials. So first we have to talk about what a polynomial is. A polynomial is in this form. It's AXN, where this has to be a whole number. That is the form of a polynomial. So it's a variable raised to a whole number exponent, and it can have a number in the front. For example, these are all polynomials. 8x is a polynomial. 1/3 x minus 4 is a polynomial. X squared minus 2x plus 1 is a polynomial. X cubed would be a polynomial. Anything that has a variable raised to an exponent, and it can even be 1, with a number in the front. Here are things that are not polynomials to give you an idea. Not polynomials. Why is that one not a polynomial? Because the exponent is not a whole number. This one is not a whole number. It's negative. So that is not a polynomial. That is not a polynomial.
What are you talking about?
1/x is the same thing as 4 plus x minus 1, right? That's why it's not a polynomial. What's the matter?
Nothing, I just wanted to make sure you're talking about the whole thing.
The whole thing. The whole thing.
The whole.
Because we're going to talk about this next, that this is a monomial, a binomial, and a trinomial.
Awesome.
I can't wait for that. So excited.
They're all polynomials, but if they have one term, they're mono. Okay? One term, monomial. 2 terms, they're binomial. 3 terms, what do you think?
Trinomial.
Trinomial.
Tell me even though
It doesn't. And then beyond 3, they're just called polynomials. Just in general. Okay? So they're all polynomials. They're in this big classification as polynomial, but how we describe them is by their terms. Which one? Trinomial? Binomial? Monomial. Mon. This is kind of silent. No, it wouldn't be. Monomial.
And that's it. And
That's an N. Like mono. Mono, just like one. Not the kissing disease.
Which is weird because it's
Okay.
plus 2 to give it, so it would be.
I had mono twice in my life, and once was when I was like 12, and the doctor called it kissing disease, and I was mortified. And I was like, no, I don't. Polynomials are written in descending order. So all this means is you're going to write it in descending order of degree. So if you have a cube, it goes first, a square second, singular. So let's say I had something like how would I want to write that in descending order?
4x to the 5th plus 3x squared plus 5x plus 1.
Good. So polynomials should always be written in descending order so they're in the right order when you're adding and subtracting.
can you develop dyslexia later on in life? Because I keep switching things. But I never do that entire life. Maybe I'm just tired.
It's a math book, I do the same thing.
There is a
It's the
dyslexia
three,
just
the
for math.
two in front, the three.
I don't remember what it's called.
It's dyslexia.
Okay, so let's talk about degrees of the terms. I used that a minute ago. If I had 2x cubed, what is the degree? 3. It's the degree of the exponent. But if I have something like this, by the way, this is a monomial because it's one term. The terms are determined between addition and subtraction signs. So this is a one-term monomial of degree 5 because you take the total of the exponents to determine the degree. What if I have 2x squared y 4z? What was the degree of this one?
6, 7.
No, 7. Good. Because that z is an imaginary 1. You get the idea. Okay, that is the degree.
And the only reason that we need to know degrees is because the order has to be in descending order of degrees.
Correct. And if you say, what is the degree of a polynomial, it will be the highest degree term. So let's say I have a trinomial, and I have all 3 of these in one equation. Okay, all these 3 I just showed you, pretend they're all in one equation. Okay? And I want to know what the degree of the polynomial is. It's the one that is highest. So it's 7. Is degree 7. So, when there's addition or subtraction between the terms, the degree of the polynomial is just the highest degree term.
Isn't that number? Is that a cube right there?
This here, here,
On the 4x to the second
squared.
power?
Yeah, but this is degree 5.
Isn't that all one right there? 3x to the third, y to the third, and x to the second power?
This is a term plus this term plus this term.
Okay, I see that. Okay. You take the highest of all of those.
You take the highest degree term, and that's the degree of the polynomial.
That z is a 7, so it's the first part of it.
Right, because it's just like this. All I did is added these 3 together. And this was degree 7. It's the highest one, so the whole polynomial is degree 7. All right. What would be the degree of this monomial? Good. Degree 8. How about of this monomial, what's the degree? 1. Did you have a question, Emily?
Why is that top one a monomial?
This is a monomial
one
because
term.
it's one term.
Okay.
If I had addition or subtraction with other terms, it would be more.
Alright.
Okay? This is a monomial, that is a monomial. How about the degree of this?
0.
Good. It's 0. Because
So
there's
it makes it a 1.
Yeah.
This is like, this would be like that, right? Because x to the 0 is just 1.
So that'd be 3 times 1, which is 0, 0.
Exactly. This is just not written,
I thought you were
but that would be degree 0. You guys are really bad today. Alright.
But is that's not a monomial, right?
Which one?
3?
3 is a monomial. Well, no, it's a constant. It's a constant because there's no variable here. It doesn't take that form of this because there is no degree. So this would actually be a constant. It is degree 0 because it could also have been written like that.
There's 3 times 1.
Except there's the 30.
So if you see a whole number, just know it's degree 0. Okay? Okay, what is the degree of this polynomial?
3.
3, because it's the highest degree. Good. Degree 3. Very good. What kind of polynomial is this? It's just a polynomial because there's 4 terms.
I'm sorry, I don't see how you got degree 3 on that. Could you go over
Okay,
that, please?
remember I said over here that the degree of the polynomial is the highest degree. What is the highest degree here?
Oh, the x to the 3rd. Okay.
Yeah. Because there's addition and subtraction in between. These are all separate terms. So this is degree 3, degree 2, degree 1, degree 0.
Okay.
The degree for the polynomial is the highest degree. So what's the degree for this?
2.
2. What kind of polynomial is this one?
5.
Binomial. Good. 5. What degree is this one? 1. And it's a binomial. What degree is this?
It's a constant.
It's a constant with degree 0. And what is the degree of this one?
6.
6, because the highest degree term is 6. Okay. And what kind of polynomial is it? Trinomial. Good. All right. Moving on from degrees. To add polynomials, or subtract them actually, subtracting or adding. Like terms are same variable and exponent. We already learned this when we were combining like terms. So it's a like term if it's the same variable, meaning x and x, or y and y, with the same exponent. So I cannot add y2 plus y3. Can't do it. But I can add y2 and y2. Okay, because it's the same variable, same exponent. Same variable, different exponent. So when you add and subtract, like terms are considered same variable, same exponent. Let's try
Why
some.
isn't that? If you knew what y was, you would still get the same answer, right?
When you're solving for y, but when you're combining like terms, you cannot combine those. Let's do one
I gotta
example.
keep doing your test as long as you guys are doing it.
I'm just glad
Fun.
my dean already knows that. Okay, so if we're adding these two trinomials, trinomial. I want to combine like terms. What is the same as 7a squared?
10a squared.
10a squared, so that becomes 17a squared. What is the same as a? Negative 3a, so this becomes minus 2a. You with me?
Yeah.
6 and 9, it's a negative 6 and a plus 9, so plus 3. I have just added 2 trinomials. That's it. That's done. That's done. Here's the next one. Okay, when we're adding or subtracting polynomials, we want to remove the parentheses, I believe, before we start adding. When we add, do I have to change anything in here? No, so I can just remove the parentheses because nothing changes. When I end up with subtraction, am I going to have to change in here before I remove the parentheses? Yes. So because it's addition, you can pretend the parentheses aren't there. What do I combine first?
5x squared next to
That becomes 6x squared. Then the 2x and the minus 4x become minus 2x. Is there anything to group y with? He's just there by himself, and the 5 is there by himself. Yeah?
Why did we smush the 5 and the x together? Why is it 6x?
Because I'm adding like terms. The x squared and the x squared are the
5x
same.
squared plus 1x squared equals 6x.
This is like an imaginary one.
Okay.
They're like terms.
It's just 5. No?
No.
Okay.
Because there's one of these. I'm adding this one to 5 of these.
Oh, because the plus means in this term by itself. Okay.
You're good? Okay. Do you notice I'm writing these in descending order?
Yes.
That's also what you need to keep up with. Okay. Another one of these examples. 5a squared b plus ab plus 2b plus 7a squared b minus 3ab minus b. To remove parentheses, do I have to change anything? No. So I can remove the parentheses. On your paper, you're not going to do that. You're going to rewrite it. But in interest of space, I'm just erasing it. Okay? Right. When it's subtraction, you'll see we have to change the terms before we erase it. Okay, what can I combine with 5a squared b? 7a squared b. So what do I get? 12a squared b. ab and negative 3ab gives me negative 2ab. 2b minus 1b plus b. Okay? Did I lose anybody? Okay. Usually we do this horizontally, but you can write it vertically in columns if it helps you. And there are some problems in your book, and I assume in math lab, that might make you do it that way. So I just at least want you to see what it looks like. So that if I were given this, and asked to add these, but they want you to do it in columns or vertically. All they're saying is line them up by term. So I'm adding 3x squared minus an x plus a 5. The reason this is nice for people to do that aren't visually seeing how to combine like terms is you're lining them up by similar terms. Okay. Then you can just add like this. Okay? You don't have to do it that way. Just wanted you to see what it's like vertically versus combining them going like this.
3x minus x, wouldn't that be minus 2x?
Minus 3x.
Minus 3x plus a negative x.
Oh, it's plus. Minus 3.
Okay, here's an example of them wanting you to do it vertically where you have to put in a 0 as a filler term. Okay, let's say I'm doing this vertically again. When I go to write this term, there's a 4x squared, but there isn't a 4x squared here. So I have to hold a space for the x squared and a 0 here, right? Because if I'm lining them up vertically, I'm lining them up by term. So I don't want to put x squared underneath the x cubed. So now I can bring this straight down like that. Okay? So if you're doing them vertically, put 0 in as a placeholder if there's not that degree term in the problem. Okay, subtracting. Minus x squared minus 7x plus 8. Now remember with adding, I said the first thing you want to do is remove parentheses, and I was able to just erase them. When I remove parentheses here, what do I have to do first?
Switch the symbol.
I have to distribute this negative. That really screws a lot of students up. So instead of x squared, it's going to be negative x squared. Negative and a negative makes this one positive, and it makes this one negative. Right? I'm going to go back and redo this. So instead of erasing it underneath, I'm going to rewrite it as negative x squared plus 7x minus 8. So I distributed the negative through all the terms before I start combining. Now I can group like terms, and I get 3x squared plus 4x minus 2.
Will we change the symbol on that side of the problem?
Yes, because look at what we're doing. We're using the distributive property. This is like a negative 1. We're taking it to each term. Sometimes it will be written this way. If it's written this way, subtract this from this. What do I write first?
The second term.
Yes. I'm taking it from this, so this is written first, minus this trinomial. Okay, that's very important to set it up the right way. Now I have to rewrite it, getting rid of the parentheses by distributing this negative. So now I get a plus x squared plus 4x minus 2. Is everybody with me? Okay, let's combine like terms. Anything to combine with the cube? What comes next?
X squared.
The x squared, because I'm writing them in descending order. What can be grouped with the x? So it becomes 7x. Lastly, I have 9 and a minus 2. So now I have subtracted these two trinomials, and it's simplified. Okay, you can also subtract in columns. So let me show you one of those, and then we'll be almost done. Okay, subtract this binomial, 3x squared minus 8, from this trinomial in columns. So what do I write on the top? X cubed plus. I don't have a squared, so I'm going to leave a 0 there as a placeholder. Okay. Then I'm going to subtract this. 3x squared minus 8. Now here's where you need to be careful.
No, wouldn't that be plus 8?
It will get there. I'm subtracting this binomial. So when you subtract, you have to take this minus into account. So 4x cubed, negative 4x cubed minus nothing is just minus 4x cubed. 0 minus 3x squared is a negative 3x squared. 7x minus nothing is just 7x. Negative 5 minus a minus 8 is a plus 3. Good. To me, the columns with subtracting leaves more room for error. I would prefer it this way. You're distributing the negative before you subtract. But I wanted to show you the columns because you may see those in the books. Or in your homework. If it was positive, then you are distributing, but nothing changes. You're just saying times 1 times 1.
Yeah, I got half of these right.
Okay. Okay, guys. Good job today. Please do your homework. There will be a quiz on Tuesday.
Okay, so before I go, I have a question.
Sure. Oh, and whoever needs to see their test, let me know.
Obviously, one of these is true and one of these is false in this question. So the polynomial, I think, is this one. But since it has a pattern,
This is not a polynomial because the cube is on the bottom, so it's actually like a negative 3.
okay.
That is not a polynomial because it's not a whole number. This one is. Okay?
I did all the homework, already through like 4 or 5, and on like the first one, 4 3 is like scientific notation. I put a like little x in there, kind of as a variable instead of part of it, so it counted wrong.
Instead of multiplication.
Yeah, is there any way to change that?
No, but you're not getting graded on homework. And like I don't look at the score in there. I look at test day if you've done it.
Oh, okay.
So I'll give you your 10 points.
Oh, okay.
So don't stress about
Are
it.
you doing the homework part or one of the quizzes? In
Oh, math lab.
In math lab, are you doing the
That
homework?
is homework.
If you do it, choose to do a similar one. You can do a similar one, and it'll
Count it?
yes,
Oh, okay.
it'll make it better.
Okay. Well, I got the right answer. It's just put it in wrong and it counted it as wrong.
Have you only been doing your math problem once?
Huh?
You've never hit similar problem before?
I do the one that's like solved like a similar one like it.
Yeah.
No, but what I did, like, because it's scientific notation, you have to put the times 10. I put like x as times and count it as an x as variable instead of an x as times.
No, I don't.
So it's it was like it's wrong.
Probably similar problem. Like,
And I have you guys' average in the class right now based on this test, if you want to know what it is.
oh wait, did you show me this to his last class?
Yeah.
Oh, I did. I thought